Hey guys, this is Carrie, and this is the answer key video for homework number 9. The population of dolphins in a small bay numbers 45 and grows at a rate of 7% each year. Write the discrete and continuous equations for the population of dolphins, P of t, in the small bay as a function of time t. So discrete, I liked the way Cynthia denoted this as the old method in class. So I think it's helpful to think about it that way. So P of t is equal to start at 45. Each year we're going to have 100% of the population we had before plus an extra 7%. So our multiplier here is going to be 1.07, and we multiply by this each year, so it'll be to the tth power. For the continuous version, that's the version that we learned in last class, where it was a equals p e to the rt. So we get p of t instead of a, because they want us to use that variable, equals the principal, starting amount, times e to the 0.07 t power. So the most important part about this problem, that's probably a little bit tricky to remember, is that for the exponential or the continuous exponential growth problems, we don't have to take into account the 100%. We saw in the derivation that 100% was actually kind of wrapped up in the e part of this equation more than the exponent. So that's our final answer for problem B. The dosage of Tylenol is 150 milligrams. The body processes Tylenol at an hourly rate of 34% every hour, meaning that the amount of the drug decreases by 34%. Write the discrete and continuous equations for the amount of Tylenol in the body A of t as a function of the time t. So I'm going to let you try to do the discrete part on your own. The continuous part is A of t equals p e to the rt, but there's a mistake here. That's incorrect. It's decreasing by 34%. So we have to make sure that our rate is negative in the exponent. For problem 3, we're going to be using the continuously compounded interest formula. Using this formula determines the nearest dollar, the amount of money in the account after 8 years if $1,000 is invested at an annual rate of 6%. So taking this formula, plugging in specifically, A of t is equal to 1,000 times e to the 0.06, not including the 100%, t power. We want to know after 8 years, so we'll do A of 8 is equal to 1,000 e to the 0.06 times 8 power. Alright, for this you're going to need your calculator, so I thought I would show you how to put this on Desmos. So on Desmos, you'll do 1,000 times, you click ABC, e to the 0.06 times 8 power. And there's a mistake here. I hope you caught it. We have to put that whole thing in the exponent, so we can make use of parentheses to do that. So let's see. To the parentheses 0.06 times 8 power. And you'll have to do the same thing with your TI-83. So you get 121,510. It says to the nearest dollar, so I think we've got it right here. So A of 8 is equal to that many dollars. We've got our units, all looking good. For problem 4, this should be really reminiscent to the practice round we had in class, which contrasts logs, bases, base e, and ln. So for problem A, we've got log base 3 of x equals 5. To cancel a log, we use a base. Bases and logs cancel out, giving us x equals 3 to the 5th power, which is 243. For this problem, we start off with base 4 to the x power equals 640. To cancel a base, we use log base 4. Doing log base 4 on both sides gives us x equals log base 4 of 640. And you know how to put that on your TI-83, but to put that in Desmos is actually a little bit easier, so I'll show you how to do that. On Desmos, we'll clear our old calculation. There is no log button here, so we click Functions, Miscellaneous, Log, and it has this little log base A. So I think we want to do log base 4 of 640. So 4 of 640, close the parentheses, and that gives us 4.661. Wow, wrong problem. 4.661. So let's delete that one. All right, e to the x is equal to 777. And if you were absent, you'd probably say the operation that you should be doing should be log base e. And this is correct, but this operation is so common that there's an alternative way to write log base e. Log base e is actually called ln. And not only is this a shorter way to write it, but it's a shorter process to enter this on your calculator. So we do ln on both sides. ln and e cancel out, giving you x equals ln of 777. To put this on your calculator, I'll show you how to do it in Desmos. Clear the old calculation, go into Functions, Miscellaneous, ln 777. So there's no fancy dividing by log of the base property here. It's just a single function, really nice. So 6.655. Lastly, for problem D, this will be the last one we go over. Oh, well, actually, we'll skip D. I think you can figure that one out. Problem E will be the last one we go over. So we have ln of x equals 3. So the same way we use ln to cancel out e, or to cancel out base e, we'll use base e to cancel out ln. So you take e and we raise base e to both sides. That gives us x equals base e to the third power. Once again, to do this on your calculator, you click Desmos, base e to the third power, 20.0855. And they didn't tell us what to round to here, so I think whatever we're rounding to. Sorry, again the wrong spot. This is actually this problem. And then for problem F, I think you can give it a shot and see if you can figure it out on your own. See you in class tomorrow.